My name is Jacob Penrod, so I'm going to be walking through the final project for CSC 578. So a little bit about my design philosophy here is I wanted to make a simple, minimally viable model that would, run efficiently, also be able to run through multiple iterations. So I really wanted to cull down my data and make my model as efficient as possible, not just add layers for the sake of adding layers and not just um, adding unnecessary complexity. Because, the beauty of design is when you're finished with design when you can't take anything away, not when you can add something. So you want to just, and that's really the philosophy I went through with here. So, first thing I did was load the data in pandas. I use pandas because it gives you nice functionality like this describe here, so I can get my description of my degrees in Celsius, which is ultimately my target. So I know things like, oh, okay, the mean, the standard deviation, the min, upper and lower quartile, all those good statistical things we look for, and I can also see, some pretty clear outliers. And that's going to come into my data preparation. So here I can visualize all my data and see some clear ones to delete. RH percentage, these are pretty useless down here because this one's just all the noise. So after that I scale and filter all the data. And then I'm dropping the columns and then I'm redoing all my graphs so I can see very clearly, okay. And then because I'm trying to minimize the number of dimensionality so it can go quickly on my old computer, uh, I get rid of ones that look very noisy, such as VDEF, and these ones that just don't look like they contribute, or they look like they're duplicating data that's in another variable. So I don't want to, have variables that basically look the same. So this is where I ended up at. I obviously have to keep T degrees Celsius, and this one looks like it gives a little bit more nuance. Even though it looks very similar to T degrees Celsius, but it looks like it will complement it well. And so these are the ones I kept. And in my model creation, I this is a very useful function. I use this in a lot of places. So this allows me to create my data frames in that 24-hour period, which is this look back. And this includes tails because in my test data sets it was leaving out the last one because that's usually the one you predict. So, you take your 24 hours and you predict the 25th hour. So I added a flag to include that tail, or to exclude and exclude the tail, because otherwise my dimensions weren't matching up when I was evaluating my data. So here's my model creation. As I said, I'm using Occam's razor and trying to make the most efficient model I can. So I only have 5 data dimensions. I'm dropping 20%. Look back is 24 hours as it's described in the assignment. I'm only using 4 neurons, so I'm creating my data sets, all off X train and test, and then reshaping them so that they'll fit inside my bidirectional LSTM, which is essentially what I went with because it's recurrent. It's a recurrent neural network. It uses context and previous and past data, so it seemed fitting for temperature prediction. Because you look at how hot the last month was to figure out if the next month's going to be very hot. It's just it makes sense at a heuristic level. So and then I have my dropout and my dense layer with the 5 dimensions, and then I'm choosing my loss by mean squared error, and I'm just kind of doing a shotgun approach to metrics because every metric seems to be useful, especially when I was doing more apocs. I originally did more apocs, but my loss went very far negative. I probably could have dropped out some of the data, but in this setup, in one apoc, so this model compiles in 8 minutes, 8.5 minutes, and only one APOC, and I get very good results. Um, so down here, I made a bunch of functions to deal with model evaluation, and I was originally plotting metrics such as the ones that I would return, and really didn't make much sense when I had one APOC, but they were very useful when I had more. But since I simplified my model, I didn't. I commented them out. So one and the other thing I really used to tune my model was this graph. So I would graph the actuals, and then I would graph what I was predicting. So the actuals are in orange, the actuals are in orange and the predicteds are in blue, so I could see where I was missing. Am I going too high? Am I going too low? Am I overfitting? Am I underfitting? So here I'm actually underfitting a little bit because on my training set it's 0.06 RSME and on my test it's 0.04. So I feel like this is a pretty good model. It fits it fits good. It might be a little simple, and that's hence the underfitting, but I feel like it is a good, efficient model, and it could be productionized because it goes so quickly, and it's also cheaper because it won't use up your cloud computing time. So that's really my philosophy behind